Welcome back, guys. In this new video, we're going to attempt to relate the ideal gas law to our old friend stoichiometry. So let's take a look here at this first part. We say in the previous chapters, we encountered reactions that involved gases. So we might be talking about gases in greater detail now, but there have been times when we dealt with gases. The first time was when we had oxygen gas as a reactant. And remember, when did we see this? We saw this in combustion. So example, we have CH4 reacting with O2 gas. And that creates, remember, combustion creates carbon dioxide as a gas plus water vapor. All we have to remember to do here is just balance out the equation. And so that would be an example where we dealt with gases in combustion. The second time when we dealt with gases is in hydrogen displacement. Hydrogen displacement, we have basically a metal reacting with an acid, HCl, HBr, HI. The metal physically kicks out the hydrogen, and hydrogen exists by itself as H2 gas. So an example, we have magnesium solid reacting with HCl aqueous. Magnesium comes in and kicks out the hydrogen. Remember, magnesium is going to connect with the chlorine. That's going to form an ionic compound because we're going to have a metal connected to a non-metal. And remember, for ionic compounds, we have to remember the charges. Magnesium's in group 2A, so it's +2. Chlorine is in group 7A, so it's -1. The 2 from here would come here. The 1 from here would move over here. So we'd have MgCl2 aqueous plus, remember, the hydrogen got kicked out and it can't exist by itself, so it exists as H2 gas. We just have to balance it by putting a 2 here and we're done. So this is hydrogen displacement. A metal physically kicks out hydrogen from a halogen. This could also happen with HBr, HI. They also would do hydrogen displacement. So now it's time for us to connect our ideal gas law concepts that we've covered thus far, plus the older concepts we learned about stoichiometry.